For DC motor, I will show how to tune the PID and how to get the closed loop operation. Okay. Closed loop operation. And BLDC, we have the hardware setup, everything over there. We kept it on the table and give the access to you. We will try to tune the PID. So I plan to go with 3 experiments in the afternoon. 1, build a simple model, the transfer function model, tune the PID, that is for simulation part, and 2 in the hardware part, DC1, BLDC second. Okay, these 3 activity we are going to do it in the afternoon. Anyone having previous experience with LabVIEW? Today is the day 1 for everyone. Okay, fine. Then I will. You are familiar. Done, sir. So I will show one small exercise with the LabVIEW. Then we will immediately go with the hardware. Okay. So whenever I open LabVIEW, I will get 2 windows. May I know the names? Front panel and block diagram. For example, first I wish to design my GUI. Which window I need to work? I need to go with, for example, first I need to design my GUI. Whenever I design a system, I will split something like 10, 80 and then again 10. First 10% of importance you will give it for your designing your GUI. What is the input and what is the output? If you clearly define this part, your program will be 10% is over. Build your algorithm and last 10% for testing your algorithm. Okay. So first I need to work with my GUI part. Then which window I need to select? Which window I need to use it for designing my GUI? User interface? I need to go with front panel. Front panel is meant for creating your input and output or controls and indicators. Okay. I wish to build one simple exercise, very simple exercise. You are from electrical, right? Any other department? Electronics and instrumentation. Electronics. Okay. So I believe you are all familiar with MUX concept. MUX. What is meant by MUX? Multiple inputs into one output. It is a circuit which takes multiple input and provide one output. For example, I want to convert 4x1 MUX. Then 4 inputs need to be converted into one output. For building that, I need to provide how many inputs and outputs are required in my front panel. For implementing 4x1 MUX, how many input and outputs are required? 4 inputs, 1 output. Do I require any other inputs? How can I convert 4 input into 1 output? The MUX circuit will do, but how MUX will work? It required 2 more inputs, something called selection lines or data lines. So based upon your selection lines, it will convert your input into output. So now I need to create 6 inputs, 4 for my 4 parameters, 2 for your selection lines or control lines, 1 for your output. What is the data type you will select? For implementing MUX, what is the data type we will use normally?
Binary.
Sir, your faculty, sir. So normally we will handle with Boolean data. If it is Boolean, all your inputs, 4 inputs A, B, C, D, let us assume 4 inputs A, B, C, D. If all of them are in the Boolean format, we will get confused like whether the true belongs to part A or part B. So input A or input B. So I will define all the 4 inputs as integer values, something like 10, 20, 30, 40. If I get the output as 10, it belongs to variable A. If I get the output as 40, it belongs to variable D. We can easily classify this. So I will create 4 variables in the integer part and 2 variables in the selection lines like a switches, buttons like on and off button, and 1 output that will display. So once our front panel is over, we go to the block diagram. Why I am doing this exercise? Before proceeding with the algorithm part, the PID part, I want to ensure that you are familiar with looping statement, decision making statement like true or false. Case structure I want to familiarize, and then we can go with PID. That is easy. Okay. So let us do it quickly. So we created 4 inputs and I will enter the numbers as 10, 20, 30 and 40 and output it will display. And for selection lines, I will add 2 switches. You can select any of them. I will take vertical toggle switch. This one ABCD numeric control. The decoration part. So basically you give priority for creating 4 input variable like ABCD, 2 boolean buttons S0 and S1, boolean buttons in the bottom and 1 output indicator. The remaining blocks I am just demonstrating how we can develop an interactive GUI. You don't need to repeat all of them, but make sure that you created suitable variables for ABCD, S0, S1 and output. S0 and S1?
Yes.
You are asking about the boundary box or
I'm asking,
S0, S1?
so is that the mux block or you just?
No, I just draw. I just draw the rectangle and inside it type it as 4x1.
We do the same.
No need to. But make sure that you created the variables. ABCD, all of them. Okay. So please create only the variables. User interface is completely optional.
What is optional? Right?
Optional, no need to repeat. Box you will ignore, but it is available inside the decoration palette. You take all of them. Create S0 and S1 boolean buttons.
So numeric values and this is numeric
Indicator.
Sir, how to get the box?
Box, do right click. Decorations, you take all of them. So first create all the variables and then you may go with your decoration part. First create the user interface, I mean the required variables. சார் அவ்வளோதான் சார், இது போதும். அந்த பாக்ஸ் எல்லாம் அப்புறம் பார்த்துக்கலாம், அதெல்லாம் ஆப்ஷனல். நியூமெரிக் இண்டிகேட்டர். Excuse me, do right click in your front panel. I'll do. So it's better to have names. If you're having only icons, it's difficult to navigate. Go to options. Function palette. Icons and text. Now we'll get it. Okay, back to the screen. We'll go to the next step. So everyone, back to the screen. So now our front panel is over. We need to connect the logic between input and output. So let us go to block diagram. So all our input and output variables are available here. First I want to implement 2 cross 1, then I will expand it to 4 cross 1. Okay. For example, in your programming language, I have multiple options. I need to select any one among them. In such scenario, which programming technique you will use? I have 3-4 options. Out of 3-4 options, I need to select one portion of the code and I want to run it. Then which programming technique you will use? For example, I have a lot of piece of code. I can call one by one, means I can use functions. I have 3-4 options like option A, option B, option C, option D, and among option A to D, I want to select only one. Then which technique you will use? Switch case or case structure. So in LabVIEW we can use the same case structure inside it, so that we can select out of 4 options, I want to select one. We can connect the one input to output we can do. So I will do right click in the front panel, sorry, block diagram. Go to structures. Inside the structures palette, we are having case structure. So it will help us to select one among them. So select case structure, draw the rectangle. So once I draw the rectangle, I have 2 options. One, the top. This one is called pages, like true, false, and then false case. So by default, it will be in the Boolean data type. I have either true or false. You can click here, either true or false. Place S0 to the question mark symbol. This question mark symbol is called as case selector. It will decide which case will get executed. If the switch is false, false case will get executed. Initially I will go to false case. False case in the sense Boolean 0. I will go to Boolean 0. Bring A inside the while loop case structure. Bring A inside the case structure. Connect A to the output. Connect.
Actually, உட்காந்து எடுக்க சொல்லி விக்னேஸ்வர் சொன்னார். சொல்ல கேமரா ஓகே ஓகே.
So connect variable, place variable A inside the case structure and connect it to the output variable, and then now go to true case. Now we are moving to true case, the second probability, and it is empty now. Bring B inside the case structure, connect it to the same output variable. So we need to connect variable A and B to the same output variable. Now go back to the front panel, run your code continuously. If S0 is 0, A is the output. If S0 is 1, B is the output. I am operating only S0. If I change the value, I can ensure that 2 cross 1 mux is working. Just to do it fast, once you completed this, we will go to 4 cross 1. Okay, do it fast.
Yes, sir.
Add the case structure, place the A and B inside the true and false case, connect the S0 and run it soon. Sir, if they need any assistance, just assist.
That is why I came in. I'm running.
And once we go to the hardware, bring that BLDC here.
DLDC here?
Yeah.
My motor.
No, 250 watts.
Quenzer motor.
Quanzer I already have brought, that is DC motor.
250 watts, sir. That is also
250 watts.
size you tell me, sir. Not capacity. I'm not sure about case studies or structures.
No, just to saying that, and it is essential for selecting the option.
Constant and all also I did not getting
Okay.
this time. He's selected all the.
Oops. Okay, let you to enjoy after reaching college. Yeah.
Sir, showing this I did A, and then
Select Control U. So Control B, Control B. It will remove all the broken wires. Connect once again. Yeah. Go to the false case. You can click here, drop down menu. Go to false. Connect A. It should work.
again this way is good.
Yes, same output.
So here or here?
Here. Same dot. No. This dot. Case structure dot.
Okay.
So when you are trying to connect multiple inputs out of the case structure, please make sure that you are connecting to the same output terminal. You should not directly connect second variable to the output. Connect it to the small tunnel, the square box available in the boundary of your case structure. Okay, you connected the first one, right? Go to the false case. Place the second variable inside it. Connect to the same thing to the output variable quick. Go to the false case. Nothing is connected. So this one having white color shadow. If you look into my screen, that has complete orange color. It means that something is missing. So place one variable here, connected to the output terminal, it will work. The boundary, I will tell you, but don't need to create. Right click, decorations. You can use these blocks to make your front panel attractive. Okay, but time being, please don't try now. We have limited time, 2 hours. So I'll just skip it. Okay, later you try. Yes. Yeah, it shows like a white color shadow, right? If you look into my screen, that is a complete orange color. I'm not sure whether it is visible or not. It means that true case you connected, A is the output. But if it is false case, what is the output? I don't know. So keep B outside of the. We'll expand this 2 cross 1 to 4 cross 1. Okay, so that we'll be having all the 4 options. Okay, back to the screen. For everyone. So now I have my second input S1. If I try to connect second input again to this case structure, I will get an error. It is not allowed because case structure is expecting only one wire or one data. If you try to send 2 data, LabVIEW will get confused. Am I taking the decision based upon S0 or S1? Then I will delete this wire. We can go to array subpalette. If I connect individually S0 and S1, I need 2 wires. But if I convert into an array, I will get only single wire. So I will do conversion of wire array. So delete the wire between your S0 and case structure. Delete the wire first. Okay. Once you delete this, go to array and then build array. Build array looks like something like this. You will be having one icon. If you place the mouse over it, you will have small blue color dot up and down. Okay. Place the mouse over the blue color dot. Your mouse will change to double-headed arrow. So when your mouse is double-headed arrow, just expand it. You can expand depending upon your number of inputs. We require 2 inputs. So limit with 2. Connect the first one to S0, second one to S1. So I am converting an individual scalar values of S0 and S1 into array of Boolean values. Now it's an array of data. For converting this, we are using the function called build array. Okay, and once it becomes Boolean array, do right click, go to Boolean, and there is a block called array to number. So this Boolean array we need to convert into equivalent decimal number. So select array to number. And then finally connect your array to number block output to your case structure. Convert into a Boolean array to number, and then connect it to your case structure. Go to Boolean array to number, build array. அங்க இருக்க பாருங்க ஸ்கிரீன்ல. Whom you want? So initially, back to the screen. Initially my case structure is in the green color. Green color corresponds to Boolean data type. Boolean having true or false. So I'm having true or false, two option. Even though if I connect, do some magic, and if I validly connect for all the two inputs to here, finally I will get only two options, either true or false. But I need four options. If I need four options, it's better for me to convert those Boolean values into decimal values. If I connect array to number block, this block to green color terminal, this green color corresponds to Boolean. It will change to blue color for integer. Okay, decimal is floating point, orange color integer. It will change to integer, and in the top the true and false is changed to 0 and 1. So now the values are getting increased. So now you do right click on the boundary, of the case structure. Everyone back to the screen, right click boundary of the case structure and select the option called add case after. If I select add case after, already I am having 0 and 1, it will add the case value for 2. So now I am getting the case value for 2. For case value 2, I will bring C inside the case structure, connect to the same output terminal. Now one more time do right click, add case after. Now I have the value for 3, connect to the same output terminal. So I have the values for 0, 1, 2 and 3. Now go back to your front panel, run continuously. 0, 0, A is the output, 0, 1, 1, 1, 1, 0. So now both your S0 and S1, your mux circuit will work. Do it fast. Yes, sir. No. Whenever you change the value, the default case is false, right? If it is changed to blue color, it started ready to accept the numbers. So there will be no false. Oh, I think that will be something. Enter it as 0. And similarly, there is no true.
It will be 1.
It will be 1. Now there is no broken arrow. Okay, you are having 0, 1, 2. Right click, add case after. You will get for 3. Connect with the fourth input. It will be over. Do it fast. Yes, sir.
Case structure I created.
Okay. Inside it, we need 4 variables. A, B, C, D, and we have to do, sir. So my best option is skip this experiment alone, sir. Second experiment we will go with inline. Okay. Sir, is it over? Shall we go to the next one? Okay. Back to the screen. Arun, back to the screen. So whenever I say run continuously for changing different input and output, how you are running your program? You are using run continuously button, second run button, or you may be, are you familiar with the loops? Morning we studied loops, right? Loops, morning? Yes or no?
We did study, sir.
We didn't study, sir. We are familiar. Anyway, if you are familiar, I'm happy. That is my objective. Okay. So whenever we want to run and see the output, that is something like only few equations are there. Then you can use the first run button. Run, you will get the output, the response. For example, I want to run continuously. I want to change something in my screen. Like we are running. While running, I want to change the input status. Like S0, S1 I want to change, or I want to change one variable value from 40 to 50 I want to change. Then we are clicking the second option, run continuously. There is one small drawback of this button. Whenever it go for a second iteration, it will reinitialize all the variables. So it is not recommended for real-time scenarios. For real-time, let us go with while loop. So I will go to block diagram. So this is my components. I will do right click, go to structures. In LabVIEW, it supports for 2 loops. One is for loop, another one while loop. So here our while loop is going to run something like a do while loop. First it will perform minimum 1 iteration and then only it will check the condition. So it's going to run like a do while loop. So take the second block, first column, second block, while loop. Draw the rectangle by including all the components in your block diagram. It means that we are placing everything inside the while loop. And when I draw the while loop, I will get 2 components. One, iteration terminal I, it will tell how many iterations are completed. While running, it will tell how many iterations are already completed. So it starts with value 0 to n minus 1. And when I go to the right hand side bottom, I have one small red color dot. This dot is called condition terminal or termination condition. Whenever a boolean true signal is connected to this block, iteration will stop or loop execution will stop. I will go to front panel, boolean. You can take any button for creating the stop option. I will take the stop button. Bring the stop button inside the while loop. Okay, so create the stop button in the front panel and go to the block diagram, bring it inside the while loop and connect these two. Once you connected these two, you can go to front panel and run it. Now I can give only single run. I no need to run continuously. Use single run, change the values. Whenever you completed your program execution, click the stop button, it will come to an end. Okay, so go to your block diagram, add the while loop, create the stop button, just to try it once. What happened?
What's the condition? While press,
It should run continuously.
No, it will run continuously until I press the stop button.
that's the
When I
condition
press
for
the
while.
stop button, yes, when I press the stop button, it will send the true signal. If this condition terminal red color dot gets the true signal, it will stop. You can
While
change it.
It is
false.
while
While false.
false, it will run the loop.
It will run the loop. You can change the option until it's true. You want to run the program. Sometimes you will get a conditions like greater than 100. Until iteration count I greater than 100, I will run.
Okay, sir.
The box, you right click the box and
You can do right click on the red color dot, and you will get an option: stop if true, continue if true. If it is stop if true means whenever you send the true signal, it will stop. Continue if true means whenever you send the false signal, it will stop. Until you send the true signal continuously, it will run.
Okay, so if I set it as continue true, if I click the stop button, it is taken as false.
Yeah, the reverse it will work. Now if you click the run button, if you keep it as continue if true, first iteration by default it will send the false signal because stop button is in the off condition. So within one iteration it will stop. Is it over? Okay, let us do a small observation here, then we'll go to the hardware part. So whenever I click the run button, I'm going to run this program for 5 seconds. Within 5 seconds, how many iterations this program will run?
Until I click the stop button.
Yeah, until I click the stop button, it is going to run. After 5 seconds, I'm going to click the button. For example, I click the run button. 1, 2, 3, 4, 5, stop. How many iterations are completed? I ran the program for 5 seconds. How many iterations are completed? Once again, I'm running 1, 2, 3, 4, 5, and then stop. Within 5 seconds, how many iterations it will run? At least give some rough guesses.
What it will do in the overnight? We are toggling the switch and the value is changing.
Either you toggle the switch or not. For example, by default, both of them are false. S0 and S1 are false. If both of them are false, A will be the output. It will display the value of A to the output variable. That's it. Within 5 seconds, I got the one answer as it will run for 5 iterations. Any other option? One iteration. Okay. Any other? Two iterations. Okay. So now we are having the iteration terminal, right? This I. All the while loops will come with. Don't do it simultaneously. Back to the screen, please. I will explain. Okay, that is my job. Okay. All the while loops as well as for loops. Both the loops having iteration count I. So we can able to get the count here. I will create an indicator. Hide it over there. Click the run button. 1, 2, 3, 4, 5. Stop. What is the number it will display? Last option. Anyone want to guess? It will be displaying in terms of lakhs. So if you go here, so it is displaying something like a 12 crore 1 lakh something of iterations which was completed. I am doing it once again. I am clicking the run button. 1, 2, 3, 4, 5. Stop. I am stopping within 5 iteration. Every iterations it is running for, sorry, every second it is running for lakhs of iteration. You are getting large number. I am asking one question. Do I need to run this loop at this speed? Do I need to run something like this? This entire loop going to respond based upon user interaction. So I am having one interaction. Whenever I make the button change, when I change the value for S0 and S1, my output is going to be updated. Otherwise, the same value. I don't need to run at that particular speed. So now I will go to right click in your taskbar, task manager. So this is my task manager. So in ideal condition, what is your CPU usage for LabVIEW? My LabVIEW software taking the CPU usage of 1%. Roughly, my CPU usage will be around 5 to 10% for running my other task. Like keep on checking my printer, keep on checking all the USBs. Other programs, like if I want to run any other program, it is going to take roughly 10%. When I run the LabVIEW, for running the same program at this much speed, my CPU is consuming from 10% to nearly 15%. That 15% of workload completely consumed by LabVIEW. Jump from 10 to 15, like 6% of CPU is consumed for LabVIEW. So I am running this much speed. Instead of this, I will go to the block diagram. I will go to timing and add one wait function. Inside the timing subpalette, I am having one wait function. I will ask my while loop to wait for 100 milliseconds between 2 iterations, or else 200 milliseconds between 2 iterations. If I specify 200, within 1 second it will run for 5 iterations. So whenever I make the change in the button, within 200 milliseconds I will get the output. So there is no lag for user interface. 200 microseconds becomes milliseconds, user won't feel any lag. Immediately it will show the output. So I will create the wait button, keep the wait function. It required one input. Right click the input, create constant, enter the constant value as 200. Go back to your front panel, run it. It is running slowly. Whenever I make a change, immediately it is reflecting. Go back to your task manager and check. My CPU usage will be again 0.1. Instead of jumping from 6 to 9%, now it's back to 0.1 or less than 0.1. The reason, I am reducing my unwanted CPU cycles. So whenever you build any real-time systems, if user interaction is involved, make sure that you are waiting until user gives some prompt or inputs. Okay. If you run your while loops without any user inputs or hardware input, means it will eat your CPU unwantedly. This is for one loop. Assume that if I am having 10 loops, something like this, 6 into 10, almost 60% of my CPU power will get wasted. Now I can able to save my CPU power. Remaining work I can able to run one more algorithm or even complex algorithm I can able to run it in the same computer. So the best thing is optimize your program so that the lowest memory as well as processing power you can use it. Okay. Add the while loop, test it with a small wait function. then immediately you'll go to the hardware part. Okay, test it once in your screen. Once it is over, you'll go to the hardware. Weight function. Yeah.
100 watt.
அது போதும் சார். 100 பார்த்தீங்கன்னா 10 times கொஞ்சம் ஃபாஸ்ட்டாக இருக்கும். ஒரு 200 250 எதுனாலும் ஓகே தான். Sir, when it comes for weight function, you can give any value between 50 to 250. Weight function output you can leave as it is, sir. No need to connect anything from the output. அதோட அவுட்புட் வந்து சிஸ்டமோட கரண்ட் டைம் என்ன அப்படிங்கிறது அவுட்புட்டாக இருக்கும். நீங்கள் 200 வெயிட் பண்ண சொன்னீங்கன்னா ஆஃப்டர் 200 வாட் இஸ் யுவர் சிஸ்டம் கிளாக் டைம், அது நீங்கள் டிஸ்பிளே பண்ண வேண்டியதில்லை, ஜஸ்ட் விட்டா போதும். Yes. This is tick counts. You do right click, empty space, empty space. Timing. Take the first row, third column. Already you are having weight function. I'm sorry. It has one input, right? Connect the one input to 200. Right? Run the program. Check the processor load in the task manager. You can feel the difference. Yes, sir. It won't display anything, sir. It will slow down your execution. Create one indicator. Right click. Create indicator. Indicator. It will display how many iterations are completed. Over. Sir, if it is over, shall we go to the next one? Everyone back to the screen. So morning you practiced with Elvis hardware, right? Did you get the chance to hands-on or only presentation? Okay, fine. We'll try one thing. I will try to demonstrate this option. This is one small add-on board. We are having the driver circuit for DC motor, and in the bottom we are having the DC motor. I will connect this one to the Elvis hardware base hardware. What we can do is, this hardware runs based upon one analog amplifier circuitry. So I can give my analog input in the range of 0 to 10. 0 to 10 voltage will get amplified and through the power driver circuit that will be given to the motor. Once motor runs, it will consume current and speed. These two outputs will be available in the analog input. I will tell you the channel numbers. First, let us simulate, create the model and do it. Once the model is over, we directly connect with hardware part. Okay. So this add-on board, I try to give 2 or 3 batches, and one more motor is available, that is BLDC motor. Both of them will work in the same fashion. Small difference between these two is this will work in the range of input signal 0 to 10. The BLDC motor take the input in the range of 0 to 5. So here the speed is in the form of analog value 0 to 1, and there you will get this analog value, speed in the form of pulses. So there is a Hall sensor will be there which will produce continuous pulses. You need to measure the frequency of square pulses to calculate the speed. Here you can directly measure the analog signal and multiply it with the gain factor to convert into speed. That's a small difference between these two. Once students are available, I will try to bring BLDC also. Okay, first let us try to complete the DC motor and tune it. Okay, for controlling this motor, we have some reference like your gain value and then speed value. Based upon the gain value and speed value, you can create it as a transfer function model for executing the PID, but for time being, I will create one linear model. Okay, I will show this procedure in my screen. For example, if you are given with any unknown systems, give something like a known value. For this system, I don't know the transfer function. Morning only I got the access to the system. So what shall I do? I will slowly change my input value. For example, if I give the input amplifier input as 0, what is my output? 0.1, what is the output? 0.2, what is the output? Similarly, I gave some known value 0 to 10, 0 to 5, and I recorded the speed values. From this, I am going to build my motor system model. For that, what I will do, I will create this range. From 0 to 1.2, always my speed is constant. Anything less than 1.2, my speed is constant. And from 1.3 up to 2.9, we are getting the variation in the speed. After 2.9, your speed will remain constant. So this is my region where my system responds. Okay, just to select this region. Once you plot the chart, you will get gain with respect to speed curve. I want to convert these values into an equation, because in LabVIEW I can able to only enter the equation. I can't give the data and interpolate. Interpolation is possible, but that won't be accurate and it's slightly difficult. Okay, so I convert it into line. In Excel, once you plot the graph, do right click and select an option called add a trend line. If you add a trend line, means it will draw one straight line depending upon your trend, and in the right hand side you will get an option like display equation on the chart. So what is the equation? So here you are getting the equation. So we are converting our speed equal to 1922x minus 2200 something. This is like y equal to mx plus c. So whenever you change the value for x, the amplifier gain, you will get the value for speed. So let us go to LabVIEW and copy the same thing. I will enter it as y equal to 1922 dot So my front panel should have one input and one output. One is gain, another one speed, your system response. I'll go to the block diagram. So this is your gain value and this is your speed. Initially, whenever the value less than 1.3, your system value goes to 0. So I will go to comparison palette. If the gain is less than 1.2, you will get one boolean statement. Okay, this is true or false. Go to comparison and there is an option called select switch. So select switch will have 3 inputs, and if you don't know how to work with this block, press Ctrl H in your keyboard. So it is giving a small description. So it has 3 inputs, true, false, as well as the signal. Signal you will connect from your K structure value. If the condition is true, my gain value is less than 1.2, I will always enter the value as 0. If it is greater than 1.2, you need to have one equation. So this is your equation. For that, go to numeric, and there is an option called expression node. If your equation having only one variable, like only one variable x is present, you can use expression node. Place it here, 1922.2 multiplied by x minus 2241.7. Give your gain as an input and provide your equation. After that, I have one more condition. Whenever the value goes above 2.9, my system is going to respond. Again, constant value. Take greater than condition. Gain is greater than 2.91. If this is greater than 2.91, my speed will be 3282. This is something like a nested loop. We are writing the equation. Okay, so I will put the logic here. If gain less than 1.2, speed equal to 0. Else if gain greater than 2.91, your speed is 3282. Else to okay. So we build the system. So now this is whenever you give the gain value, the system is going to take the speed value as an output. So next step, you will put the PID, give this as a model for your system, tune the PID in the simulation part, you connect the hardware second. Okay, do it first. Expression node will be available in your structure palette. You can go to structure, numeric, and then expression node. ஆமாம் சார். For 1.2, it will go to the equation and it will provide the output. So it should not go to, put it as less than 1.29. Put it as 1.3. 1.3. Just enter it. With the equation 1. Here you are getting the data. It's not a real-time system. If you want, do it, no problem. Actually, 1.2 also goes to 0. The next option is 1.3. No problem. Okay, so back to the screen. I'll make small changes in this module. So now we are in the value of 0. I will slowly increase like 0.1, 0.2, I am slowly increasing. When I increase it like 1.2, 1.3, my speed is getting increased. I am entering the values, numerical values directly. Whenever I go with any number from 1.7, if I enter the value as 2.6, if I click enter, immediately my output speed will change. But it won't happen in the real time. I need to give the real time, the gain value slowly increase, or even the gain is increased. Motor will take some time to accelerate and decelerate. That value we need to enter it, or that parameter we need to model it here. For simplifying the model, what I will do is I will go to the block diagram. I will make a change in the gain value. Whenever user enters some value, it won't increase immediately. It will take some time. It will slowly increase and decrease. I am going to make the change in the gain value. I will add one case structure. I will add one case structure and compare my present gain value with my previous gain value. How I will get previous gain value I will show shortly. I will compare my present gain value with my previous gain value. If my previous gain value is less than, sorry, present value, I need to increase. So I will add kind of 0.1. This is your actual gain. Go to structure and select feedback node. Go to structure and select feedback node. Pass this value as an input. Whatever the gain value I entered, if it is less than actual gain value, then I will slowly, sorry, if it is greater than, if the given gain value is greater than actual value, I need to increase the actual value to the user entered parameter. So I will increase by step of 0.1. If it is false means that is less than, so I need to subtract previous value with 0.01. So I am making a small scenario. Whenever user changes the gain value, it won't reflect in the motor output immediately. It will slowly increase or decrease. So I will click the run button, run continuously. For user, and even though there is a gain value, it will run too fast. For user understanding, I will create a wait function. Later I will remove it. Okay. I am clicking the run continuously button. So the gain value, actual gain value, you can see their value is getting increased slowly. So the motor will slowly increase the speed, and similarly if I reduce the speed value, it will reduce gradually. Instead of suddenly increase and decreasing the values, we are making slow increase and decrease. I'll go here, delete it. So this is your motor model, the simplified version, the linear model. So one input is your gain value, another output is your speed. In the right hand side, the top corner, you will have some square blocks will be there. It is called as connector pan. You can use this one for defining your arguments for your sub VI. So left click the one of the square block available in your connector pan. For example, I am making the first one. It will be in the black in color. Go to your gain, do left click, and right click on the another block. Left click on the block, right side block, and connect to speed. If these two blocks, if I connect, means those variables will be kept as input and output for your sub VI. Save your program. I saved this file as motor model. So I have one input and one output. Call your new VI. So inside the new VI, I can go to select VI option. I can go to select VI. I will get file browse window. Navigate into your motor model block. Place it here. Control H. So this function, earlier we created this function having one input and one output. So that is gain, output is speed. You can do right click and select edit icon. I will delete this icon, default icon, and make it as motor model. To give a comment, save your file. So this is going to be my motor model. I will build the block, stop button. This is my set speed. Right click and go to control system and simulation. Under the control system and simulation, select your PID. Take simple PID tuning, manual tuning. Okay, take the block, place it over here. Since it is a new block, I don't know what is my input and output. Press Ctrl H, it will give the explanation. So my first input is output range. Output range is your gain range. So the default value will be -100 to +100. For our controller, the output range is 0 to 5. 0 is your lowest value and 5 is the highest value. So enter the output low as 0, output high as 5. So this is something like a saturation blocks output of your PID. And the second input is your set point. Set point you will directly connect set point value, and then process variable, that is your actual speed. You need to take it from the motor. Structure, take the feedback node. Third input will be PID gain. Right click, create, control. So in the front panel you will get gain values for PID. Next one will be the DT, the time difference between two iterations. So here whenever I click the run button, the system will try to run at the maximum speed. So I will create the wait function and give the time delay as like 50 milliseconds, and the same value you will give it as an input here. So here I will take the input in the form of milliseconds. If you check this block, it will tell milliseconds to wait. Your unit is different. So here I will enter 50 directly. So here the dt is in the form of seconds. Dt within the bracket I am getting the unit as seconds. So I will enter it as 0.05. This is your output gain value. You connect it to the input for your model block. So I will create one slider. To check what is your gain value, create it as an indicator and connect. Take the waveform graph. So I expected to plot my system variable and process variable output. Right click and go to cluster, select bundle option so that you can plot multiple variables. Take bundle, connect the first input to your set point, second input to your actual gain value, the motor output, and connect it to waveform graph. I am setting the initial set speed as 1000. So slowly I will increase my proportional gain value. Initially I am keeping this proportional gain value as 0, and remaining Ki and Kd value I will keep it as 0. So initially I am slowly increasing my gain value from 0.1 to 0.001 to 0.002, 0.003. I kept as 0.8. Whenever I create 0.008, I am trying to get the constant error. Constant error in the sense your variable in the output is something like 790 to 820 and 1000. Nearly 180 to 200 RPM a constant error. If I reduce this value, your error band will increase. Like instead of 180, 200 RPM, 300 RPM or 400 RPM. Make sure that initially you are getting 60 to 80% of your original value. Whenever you want to tune manually, before achieving your touching your integral as well as derivative gain, slowly increase your proportional gain value and get the constant error. I want to check this constant error. So increase the speed to 1500. Your system should respond. It should increase your actual gain value, and so output also need to increase, but there should be a small band will be there. And once you get the 60 to 80% of your band value error, then you start touching the next parameter of integral gain value. Whenever you increase the integral gain value, it will go to peak overshoot. The system will cross your set point, it will go to the maximum point and come down, and it will start oscillating the values. It will go closer to your system parameter. Like I am setting the second one. Okay. Then either you have two options. Once you started to get the peak overshoot for your integral gain value, either slightly increase your integral gain value and achieve your set point. Now I am achieving 1500, I am increasing to 2000. Started to get the tuning the value. If you want to reduce the damped oscillation, then slowly increase your derivative gain values. Now my error will be 1987, something like within 30 RPM my error was reduced. Initially I was unable to get the error, then slowly you can able to tune it. For this system, since it is a very linear system, you can achieve the set point by using only proportional and integral gain value. When you are having the actual systems, you will start facing your disturbances, and then only you will touch your all your proportional, integral and derivative gain values.
So like MATLAB doesn't have auto-tuning.
Auto tune is there, sir. For example, if you want to tune it automatically, I don't want to spend time on manual tuning, then under the PID, I took the first PID block, take the third PID block. So this function having auto tuning PID, what it will do is it will have the PID gain values and auto tuning parameter and one boolean button. So when you select this auto tune boolean button as true, depending upon your set points as well as the actual reference value, it will generate the gain values. Once you get the output as tuning is completed and tuned PID gain values are available, enter the same values in your gain, PID gains manually or using local variables, then your system will run normally with the tuned values. So now I have one DC motor. This motor speed I am going to vary by adjusting my voltage. We will measure the speed and tune the same system in the hardware part. So I will go to Measurement and Automation Explorer. I want to connect with the hardware. So for connecting the hardware, I need to go with any Measurement and Automation Explorer, DAC MX and DAC Assist. First what I will do is I will generate the analog output and ensure that my motor is running. I want to generate the output, analog output in the form of voltage. So select voltage. So here channel configuration is analog output A was 0 is connected to the amplifier input. So select A was 0. So you will get the test window. I will enter the value as 0 and there is no response from the motor. I will enter it as 1.2, apply the value. So now my motor is running. So my motor is responding for my amplifier input. 0, apply it, click OK. I will take one slider. So this amplifier having the gain of 1. Since you selected this as continuous sampling, LabVIEW is recommending to put the while loop, that is for continuous operation. So select yes. So first while loop, this is for